Hey, Sai, how's it going?
Hi, Sally, and I'm doing well. How are you?
Can't complain. Excited for our reading today. We'll give folks just a few minutes to join us, but let me go ahead and share my screen here while we wait. We'll just do one more minute and we'll get started. Hey, everyone. Thanks for joining us today. We got a really exciting paper reading on a technique called RAFT. And what's really great is we actually have Sai here with us who participated in the research. So extra special treat. Um, I guess let's go ahead and get started. We'll start with intro. So I'll start on my side. Hey everyone, I'm Sally Ann. I'm a product manager here at Arise. I help build out the product and as well as help our customers, get the most value. And with me today, I have Sai. I'm gonna go ahead and give an introduction.
Hi, everyone. My name is Sai. I currently am interning on the backend side of Arise, and I also do research at Berkeley. And this is actually one of the papers that my lab produced. So, kind of excited to introduce you guys to it.
Yeah, well, I'm super excited to have you here. It's always more fun when we have somebody here who's participated in the research or is an author on the paper. So I think you have a really great perspective and excited to go through it. Before we get to that, I do want to give a little shout out to our conference that's happening in just about 2 weeks here. It's happening in person in San Francisco at Shack 15. You can use the promo code RAF50 or use this QR code here for a $50 ticket. So really great savings. It's going to be an awesome event. We have so many great speakers, people from Anthropic, Mistral, OpenAI, Microsoft, Meta, Wayfair. You see them all at the bottom and many, many more. It's definitely going to be a great time. I'll be there, so come and say hello. But yeah, feel free to go ahead and use this code here to get your ticket. All right. So for today's agenda, we're going to do a background and intro into RAG and fine tuning, just set the scenes, really important to understand those. Then we'll get into RAFT, go through the training test time results, and then Sai and I will give you our closing remarks. So with that, I'll hand that over to you, Sai. Go ahead.
Yeah, of course. I guess we're just gonna, I'm sure most of you already know what RAG is by now. For those of you that don't, this is kind of just like a illustrative diagram. Essentially, you have like documents that you want to use to help your LLM answer questions. So you can do whatever you want with them. Like you can host them in like a vector store or like some sort of database. And then you essentially, when you have a query, kind of perform like a similarity search between the query and the documents in your document store. And then use like the most similar documents to help your LLM answer the question. I'm sure most of you already know about this, but we just wanted to kind of do a slight overview just in case.
Well, yeah, we see this framework a lot with our customers and just I feel like in the community. So in case anybody wasn't sure, it's good to just give a layout here. We'll chat about fine tuning.
Yeah, so then fine tuning is kind of like the other big thing that we're going to be kind of talking about today. So it's essentially just customizing like an LLM that's already pre-trained on additional data or like a specific new task, just so that it performs better than if you kind of just used it out of box. And this is important because this actually ends up improving like the LLM's performance for specific tasks like greatly compared to other situations like RAG. But the issue is that it tends to be a lot more knowledge intensive. You need to have like a lot more behind the scenes knowledge of these models to kind of make this happen. It's also just a lot more computationally expensive.
Totally. I think there's different use cases too, RAG versus fine tuning. I think RAG can do really well when you have kind of this need for in context knowledge being passed to the LLM, whereas fine tuning is really, more helpful for those situations where you have a specific task in mind and you want to fine tune the LLM just to provide that single task there. Um, cool. So you kind of hinted at already, but go ahead. You
Yeah,
want to tell me
exactly.
about
So
fine
just a
tune?
little bit about why you would actually want to fine tune. Um, Oftentimes you get better performance. So by fine tuning the models, you end up getting better results for specific tasks or specific domains. And then essentially fine tuning sometimes can make a really small model even outperform maybe a bigger one. for a very specific task. So that could also be a reason why, just kind of from like a cost perspective, or like being able to use like less resources. And then last thing is differentiation. Most people can't train like a foundation model from scratch. Like none of us are going to be able to create like ChatGPT from scratch. So fine tuning with our own data sources kind of helps us create a model that's a little bit more customized to what we want.
Totally. All right. Yeah, you want to talk through the challenges of fine tuning a little bit? So we kind of just touched on why you would want to fine tune, gets better performance. It could be cheaper and faster. Definitely don't want to spend all that time, training a foundation model. But what are some of the challenges here?
Yeah, of course. So, I mean, everything sounds good about fine tuning, but when it actually comes to practically implementing fine tuning, there's three main challenges. First is data. Oftentimes, we don't really have access to a lot of data. For fine tuning to be effective, you kind of want to provide the model with as much data as possible. A lot of times, this data can be very expensive to parse or kind of gather. So that's one of the biggest issues. Another thing that I kind of alluded to before was computational horsepower. It takes a lot of GPUs and a lot of computational power to be able to fine tune like a model to a specific use case. And oftentimes in industry, when you're trying to launch a new product, this is kind of just not feasible. And then lastly, also alluded to this, fine tuning requires a lot more expertise and understanding of like the behind the scenes of language models compared to like maybe like a RAG system, which is a lot more easy to understand and implement. So those are like the three big barriers to actually using fine tuning in production, I would say.
Totally. Yeah. And I think some of these are getting better. I think we've seen that some smaller samples of data might be enough to fine tune, and there's certain things out there. I think, the computational aspect of it, we haven't seen too many improvements there. We have seen maybe some fine tuning methods that kind of help you, constrain your resources there. But yeah, these are definitely challenges that we hear. I want to touch on this quickly before we dive into RAFT.
Yeah, and then just like a last slightly overview, kind of just wanted to give like a diagram to kind of visualize what happens in actual production and industry. So the first step for anyone trying to improve like model performance would be prompt engineering, seeing if maybe like wording the question or the query differently could get better performance. And then after that, typically is when people move into like a RAG-like system where you bring in other context at test time to help your LLM perform better. And then lastly is fine tuning. And this diagram just kind of shows that as you kind of go down, the technique might be more effective, but also more costly. So it ends up being used less frequently.
Totally. I think something important to call out too here is like a lot of times what we see is it's a combination of a lot of or all of these kind of together. There's some prompt engineering, retrieval, and then fine tuning. You don't have to use these kind of independently of each other. And I think that kind of gets to where your research group is going with this concept of RAFT. So let's get into it.
Yeah, so this kind of is a good segue for us to introduce what RAFT is. In full terms, it's retriever aware fine tuning. So as some of you can probably kind of interpret from the name, essentially it's a way to kind of incorporate fine tuning and like a retrieval system to be able to better identify which documents are most helpful for the LLM. So we'll kind of start off with kind of like an exam analogy, just so that I can kind of explain it in layman's terms. So traditional fine tuning, we can kind of relate that to a closed book exam. So you learn all of the information beforehand and you memorize it. And then when you take the test, you kind of just have to recollect from your memory. Whereas like a RAG system would be an open book assessment. So you have some sort of base knowledge, and then while you're taking the exam, you're allowed to go through your textbook and kind of try to find the answer in there to kind of help you answer the question at test during the test. But now how RAFT is different is during the exam itself, you still have the textbook, but during your memorization and your like studying phase, you actually understand how to use the textbook properly. So when you get a question on a test, you're able to kind of identify which chapter you want to go to or which section that you want to go to. Then you focus on that section so that you're actually able to get the right answer. So it kind of just teaches you how to use the textbook effectively by incorporating both methodologies.
Really, and I think that that last part there, it teaching to use the context effectively, like we're going to get into it, but I think that's really like the meat of this research here and one of the most important parts. So we can dive into that a little bit more here.
Yeah, so I guess we'll start off by talking about like the training portion of RAFT. The way this works is we do like a traditional supervised fine-tuning of the model, but what we do is we provide it documents that act as distractors. So these documents don't contain the right answer. And then we have one couple of golden set documents which contain the answer that we need. So if we look at the example on this slide, let's say our question is who invented transformers? So during this fine tuning stage for the LLM, we'll give it documents that talk about Atom, we'll have ResNet, which don't relate to like the inventation of transformers. And then we have one document, which is a golden set that has attention is all you need. And that is the paper that kind of introduces transformers to the world. So now during training, we kind of show the LLM that the right document is attention is all you need. So as the LLM keeps training, it's able to understand which document is the right one and how to kind of pick that up. So just
right here.
yeah. So just like a little bit more of like a detailed overview of the training data set preparation. So there's four major components to the data set that you need to train the model using our RAFT pipeline. So the first is the prompt or the query that needs to be answered. The second is the golden document, which is a relevant document or a set of relevant documents that contain the information that is actually needed to answer the query at hand. And then a set of distractor documents. So these are documents, as I mentioned, that do not contain information relevant to the query, but they are included because oftentimes in the real world, even with the RAG systems, there's a high probability that even if you have a high similarity between a document and the query, there's not actually any valuable information in that document. So this is kind of trying to simulate that by providing distractor documents. And then we have the correct response, the answer, which is formulated in a chain of thought style. And essentially, we'll get more specific into this in the next slides, but essentially it's kind of just a paradigm for the LLM to go through the documents, identify the relevant parts of the documents that it used to get that answer. So by training the document to or training the LLM to do this from the start, it's essentially learning how to go through each of the documents, identify the relevant parts of the documents, and then use that relevant information to answer the question. And then just one more tiny thing to touch up on is the data split. So essentially P% of the data contains the question, the golden document, and the distractor documents. And then 1 minus P% of the data contains the question and only distractor documents. The reason why we do this is we don't want the LLM to kind of get biased towards always assuming that there's some sort of like golden document. There's lots of cases in real world when none of the documents you have in your RAG system are actually useful for the user's query. So to kind of emulate this, we actually have a subset of the data where there's no golden document at all. So all of the documents are irrelevant, and the LLM has to kind of learn to also understand this. This is just kind of to keep it true to itself and not biased towards one one style of thinking.
Totally. Yeah. I mean, it is definitely a common issue that we see, like, the whole conversation of, similar is not always relevant. And that's a common problem that you have with these RAG systems. They're built on, like you touched on that very first slide there, on a similarity metric. So we're looking at these embeddings and we're grabbing something that's similar to the user's query, but that doesn't mean that it has the answer. So this is definitely something that's required to have a robust RAG system. I'd be curious, I'm not sure if we were going to touch on it in one of the later slides, but in the paper itself, you and your group talk about wanting a certain percentage of distractor documents to kind of and have this improved robustness for your RAG system. Can you talk a little bit maybe about how the group determined like that optimal proportion and how you decided kind of how many use cases in your data set to have only, your distractor documents?
Yeah, of course. So I think it was just kind of like through a series of iterations. So we kind of just experimented with different percentages. I think we'll get into this a little bit more later,
Okay.
but it was just kind of an idea, like for research purposes, we kind of experimented with different quantities and then kind of figured out which ones work best for each data set. But I think it's also kind of just one of those parameters that you need to optimize for your specific use case. Sometimes it might make sense to include like a larger set of data with no ground truth versus including a larger set with the ground truth. So it kind of just goes into your specific use case, and I would say it's something that you should kind of optimize for in specific use case.
Totally, yeah. So treating kind of like a hyperparameter almost, it's kind of an interesting
Exactly.
call. It sounds like we'll get into more detail, so I'll save some other questions for when there. But we do have a question from the group here. The question is, in RAG, LLMs are good at filtering out completely unrelated context, but they tend to fail when documents are relevant but not actually quite applicable. How were the distractor documents chosen to fit this criteria? Was this something that the group thought about at all?
Yeah, so I think the short answer to that would be we kind of tried to include like some documents that were similar to the ground truth and then some documents that were completely different,
Hmm.
just so that we kind of encompass like the whole wide range of like possible situations. Because it, like even like let's consider like a real case scenario with your RAG system, you could with similarity search, some of the documents could actually be kind of relevant, but not
Mhm.
contain the right answer, whereas some are just not relevant at all. So we kind of emulated that by using like a mixture of documents that were completely irrelevant and then some that were getting more relevant. So I guess if you go back to like the slide with the example of the transformers, so like if you look at this, Atom and Glove might not be related at all, but ResNet could actually be maybe a little bit closer to the true answer. So we kind of just try to like vary that composition and just have like a wide range of documents that encompass all the like different scenarios.
Totally. So there's a certain level of like curation that you all did to do your best to kind of emulate what happens in the real world, where you can get something that's related but doesn't have the answer, and something that's completely unrelated altogether.
Yeah,
Makes
for sure. I think that's also like an interesting topic to bring up. I think future work, it'd be really cool to kind of like explore all these different scenarios, maybe like a scenario where all the documents are completely irrelevant, and then a scenario where all of them are like almost exactly relevant, like really close to being relevant. So I think that'd be cool if like someone could kind of explore that and then see what the results are that way.
totally. Yeah, it would be interesting to see not only how, it impacts the answer that the LLM gives, but just kind of to see how effective this technique is. Um, so let's go on. Oh, there's another question in chat, but I think we'll circle back to it in a second there.
Yep.
Yeah, let's talk about chain of thought. I thought this was super interesting, part of the paper.
Yeah, exactly. So RAFT uses the chain of thought style for generating answers. So this essentially, long story short, this means that the model is trained to kind of provide the reasoning that leads to the answer. So when we kind of prompt the LLM, we don't just go, okay, use these documents and then give me the right answer. We kind of tell it, go through these documents, give me the relevant parts of the documents that you're using, and then answer the question. So this structured approach kind of helps the model better navigate through the mixture of relevant and irrelevant information, which then ultimately kind of makes it better at reasoning and extraction. And we have like an example of this in a couple of slides coming up as well. So we'll get a little bit more detailed about that later.
Awesome. Yeah, I think chain of thought is a super powerful technique Specifically anytime you're doing any type of research and you're trying to understand like how the LLM is formulating thoughts, but I think it also just helps LLM perform better when it's, you know, required to kind of go through and think. You can think of just how any human were to reason through something, there's a chain of thought, right, that happens to arrive at an answer. So I'm really interested in this, and I think you have some slides coming up that will we'll dive in a little bit deeper on it.
Yeah. And then this is kind of just like an illustration of test time. So now you did the fine tuning part of RAFT, and now you are like, we actually want to be able to use the model. So what happens? So now, again, like a traditional RAG system, now we have our fine-tuned LLM, and then we pass in the similar from our like document store. We similarity search with like cosine, like whatever type of similarity search you want. You retrieve these documents and then pass that into the LLM with the query. And now the LLM is able to output the answer. But while it's generating the answer, now because of the fine tuning, it knows how to eliminate the distractor documents and kind of focus on the document with the ground truth. So
Yeah.
essentially, the test time, like inference part of RAFT, is kind of emulating like a regular RAG system, just that the model is now so much more like so much more accustomed to kind of getting the relevant part of the information.
Totally. So at Inference, nothing really changes. It's all about that kind of fine tuning that you're doing. It's the data that you're providing for fine tuning the structure of that, including you know, those documents, some distractors, some not. And I think the chain of thought was also provided in that the fine tuning data set, correct? You gave kind of the ideal kind of chain of thought there.
Exactly, yeah. The reason why we provide the chain of thought reasoning as the answer in our training document,
Mhm.
our training data set. And the reason we do this is because the LLM was trained to respond that way. Now, when it kind of produces an answer, it's inherently using that chain of thought reasoning to generate the answer. And obviously, I think as many studies have shown, chain of thought has been very effective in kind of improving answer quality.
Yeah. I think that's really important. I'd be curious to learn a little bit more about your process there. It's kind of going back to, I guess, one of the other slides of like how you all went about generating those chain of thoughts for the training. Was that something that you leveraged another LLM to do? Was it kind of, you know, manual where you all in the group kind of provided the correct chain of thought? How did you go about doing that?
Yeah, so I guess the four main data sets that we used were like a medical data set, PubMed, HotpotQA, which is kind of just like a general question answering data set, Hugging Face, which is for coding like APIs, and then we also use like an in-house data set called from Gorilla LLM, which is kind of just like tool calling for APIs. So
Mhm.
a couple of the data sets, they actually had chain of thought answers as the traditional answers within the data set. So we didn't have to perform any more like any modifications to that. But for the other data sets like Hotpot QA and then PubMed, we passed in the answers to the Oracle, like an Oracle LLM set, let's say like GPT-4, or
Mhm.
now I guess you would use like GPT-4o, and we kind of had it come up with like chain of thought reasoning that way,
Gotcha.
and then we curated the data sets that way. I mean, I guess it depends on the specific use case. If you have the capabilities to kind of generate chain of thought reasonings yourself or like your team, then you can curate the data set that way. But it's just a lot easier to kind of have like a really strong LLM do that for you.
Totally. I think we see that a lot with these techniques of this synthetic generation. I mean, the models are so good these days that you can rely. I think, you know, you do want to have some kind of level of human evaluation before you just automatically assume that it's of high quality. I think in a lot of the research that we've gone over, you know, previously, we've seen that the quality of the data is one of the most important things. And there was one point where, you know, volume mattered, but now we're actually seeing that you can get really good results with a smaller data set as long as it's super high quality. So it makes sense that you all kind of you leveraged what you had from those, you know, data sets that you've chosen. And then, you know, you leveraged, you know, an LM to do some synthetic data generation.
Exactly. Yeah. And then just like even for the synthetic data generation, we used our examples. For some of the questions, we actually did generate our own chain of thought reasonings. and
Hmm.
then pass that into the Oracle LLM to kind of use that as the backbone for its chain of thought answers. So we kind of got everything in like a format that we wanted.
Totally. So we did some, a few shot prompting there to get the LLM to give
Exactly, yeah.
those chain of thoughts that you were looking for. That's awesome. Um, cool. Well, let's keep going. I might have some more questions for you. Let's oh yeah, this is great. Example
Oh
question.
yeah. Yeah, so this is kind of what I was alluding to earlier. Um, so let's say our question, you guys can read the question, but we have a question for our like RAFT LLM, and the next slide would be the context. So this is the context that you would retrieve from your document store, and it just has a bunch of information relating to the query through similarity search. And then now this is our instruction to the language model. So we say, given the question, the context, and the answer, provide like a logical reasoning for that answer. And then use the format of reason and then answer. So that's kind of where the chain of thought reasoning comes in. We tell it to kind of provide its reasoning first and then answer based on that reasoning. And then, yeah, this is kind of the answer that the model produces after. So as you can see, it has a reason, shows like the document chunks that were the most relevant, and then it kind of provides the answer after. So this is essentially makes the LLM use the document, use like the relevant parts of the documents to answer the question as we intend.
Totally. It's almost like you're making it cite source, right? You can't just give an answer for no reason. You gotta cite your source there. Um, very cool. Let's talk about the results. I thought these were really interesting.
Yeah, for sure. So as it can, or I guess I'll go through like um the term DSF. That is just kind of the fine tuning part of our RAFT pipeline. So the RAFT pipeline without using like the RAG at inference time. So no RAG is just DSF. And then DSF plus RAG would then kind of go into our RAFT pipeline. So as it can be seen, for 4 out of the 5 data sets, using our RAFT pipeline actually improved the performance quite a bit compared to other like iterations of the models. And it honestly does better than like GPT 3.5 with RAG, which is really impressive because we're using an open source llama model with only 7 billion parameters. So the model is not necessarily the strongest offering on the market in terms of open source, but it's able to kind of match the performance of GPT, which is really interesting to see.
Yeah, something I really appreciated, reading through this paper is just you have all these different comparisons. You have just like a base model, then you have it with RAG, but then you also have fine tuning, then fine tune with RAG. So you can really just see like across all of those different scenarios, RAFT is really outperforming. And I think it makes a lot of sense if you think about what you all have done with this research. I think it's a very common problem of getting the LLM to attend to the pieces of context that it should be and actually making use of them and not, hallucinating an answer. And so the idea of training it on how to use the context, I think, is obviously very powerful. And we see that in the results here. I'd be curious if you guys explored, the role of kind of prompt engineering as well. Like I'm specifically curious if there would be any use cases where maybe like the prompt engineering would be able to kind of help the LM's ability to ignore, irrelevant context, or like where you maybe see the gaps in terms of prompt engineering.
No, for sure. I think the prompt engineering is something that the lab didn't really focus on, the authors didn't really focus on for in terms of this paper. So we kind of just stuck with like a very simple like prompt instruction and kept it kind of simple. But I
Totally.
think that is definitely one avenue for future research. I think being able to optimize that better would actually for sure improve performance. By how much, we don't know, but I think it definitely will make some sort of positive impact. And for accuracy, even like a little bit of an increase means a lot for like actual use cases. So I do definitely think that kind of experimenting with the prompt engineering will help the LLM produce better answers for sure. And then I guess another thing that I wanted to point out from these results is, as you can see, for PubMed, and all of like the coding sort of API data sets, our model did a lot better. But then when it was like a general question answer data set like HotPot, it didn't quite beat like traditional ChatGPT, and it did even worse than some of the other models. And one this kind of goes to like our understanding or one of our takeaways is that RAFT makes a lot of sense to use when you have a very specific domain or like something where you have a use case that's differentiated from like just needing general information. So in the case of HotPot, it has questions spanning from various different topics. There's not one general theme in the questions. So it makes sense that RAFT didn't really perform better than just using a traditional RAG system because there's not really much to fine tune on because the questions are so diverse.
I think that's definitely a really great call out because I think a lot of people probably today who are listening in on this, their probably question is, when exactly should I be using RAFT? And I think you might read this paper and be like, oh, anytime I'm doing RAG, I should be using RAFT. And I don't think I agree with you. It's not necessarily the case. I think you really have to consider, the domain, the task itself, and decide whether or not, RAFT is worth the investment. Because, fine tuning these models does require cost, it requires time, resources, all of that, and it just might not be necessary. So I think maybe doing a little of research on your own and testing out this might be a good call there. We got some questions in the chat. Let's maybe go through those quickly. So we have one question here where they are trying to do, HR, FAQ, probably, RAG chatbot, just about 200 questions. If they were to want to use RAFT, how many questions would we need to prepare for the training data set? That's always a tricky question that everyone wants to know. I
Yeah,
have some thoughts, but what are your thoughts there, Sai?
I think from like my take on it is do what makes sense to your specific use case. I think there's not one general answer about like the number of questions you should have in your data set, right? Like obviously the more training data you're able to provide in the fine tuning stage, the more customized the model is to your specific use case. So kind of just really depends. I think as a general use case, 200 does seem kind of like on the smaller end for a data set, but it honestly just kind of depends on your use case and just I'd say just kind of experiment with it. But I'm sure Cyan can talk a little bit more in regards to that in terms of like actually using this in industry.
Totally. I think everybody wants to know what that golden number is for fine tuning. We had that same question, back in the traditional days of how much data do I need? And I unfortunately just don't think there's a good answer. I would say that you could maybe get away with 50. You might need all 200. You really won't know. I think it depends on the quality. And as Sai mentioned, exactly what the task is. Something with like a simple kind of RAG system for just answering kind of HR related questions, you might be able to get away with a smaller number of data sets because it's just that breadth of knowledge that the LLM needs is just not very wide. So I would say make sure that you curate some really high quality examples, and you could always start small and expand, but at 200 you might be able to just kind of use all of those, but just definitely make sure it's high quality. I think that's the key to fine tuning here. We have another question around fine tuning. This specifically is about how you all took precautions around, catastrophic forgetting. Did you guys account for that? Was that something that wasn't necessarily top of mind for you all?
Yeah, we do have some ablation studies. So in the if you look in the paper itself, we do have some studies. So we kind of tested RAFT without using chain of thought reasoning. So just using like normal like question answer type of prompts, and then also just some other ablations as well. So if you kind of read the paper, there's a little bit more specification on that. But obviously, that wasn't necessarily too much of our focus in this paper. Our focus was more so trying to kind of effectively bridge the gap between just having to use RAG or like fine tuning, kind of like being able to use both in a sense. But I would definitely recommend reading the paper. There's a lot of ablation studies on there, a lot of information that we provide there that can answer your question better.
Totally. All right, cool. I know we're running low on time here. Let's get through the rest of this. You got a lot of good information here.
Yeah, for sure. And then I guess one other kind of thing we looked at in the paper was during test time, like how many documents do we use? So for natural questions, we got the best results when we used like 3 documents as our top K, whereas in HotPot, it was 1 document. So 1 document as a distractor and then like a golden document. And then for natural questions, it was 1 document and then 3 distractors. So I think that also kind of just goes back to what I was talking to a little bit earlier, that in HotPot it doesn't make sense to have like as many distractors just because the questions are so general. Whereas in natural questions, the questions tend to have more of like a specific type of guidelines, specific type of format, and they're a lot more similar to each other. So it makes sense to include more distractors. So it really just goes to show that you need to understand your data set really well to kind of figure out if RAFT makes sense to use. Because in my opinion, just kind of looking at these graphs in the HotpotQA graph, I don't think it makes sense to necessarily even have to use RAFT. Whereas in natural questions, it makes a little bit more sense to use.
That makes a lot of sense here. So I think it would be fair to say that, you know, there is kind of this varying robustness when you introduce, you know, maybe different numbers of documents at, you know, test time there. So that's something to kind of keep in mind. And I think this could be another potential you know, I think research avenue around this of like how can we ensure, you know, consistent performance really when you're having kind of that varying K at test time. Right.
Yeah, and then just kind of throwing in just a little message from my team at Berkeley. Obviously, it's a procedure. Like as I kind of mentioned, the analogy, it's like learning how to actually use the open book when you're taking the test. And yeah, just kind of next slide. If you're doing RAG, you should be doing RAFT. Sometimes I think from like an academic perspective, it makes sense to kind of use it all the time. But in terms of production, just make sure like you actually understand your use case and you're careful about like what your data set is actually looking for.
Totally. All right, let's go through our takeaways the last few minutes here.
Yeah, for sure. I guess I can start this off just because I know this is at the top of the slide, but I was kind of talking about this the whole time. It's really useful for settings where the documents might have like a unique format or the topic is very obscure. Not necessarily worth the extra work during implementation for traditional document sources. So what do I mean by this? Let's say that your RAG system is just kind of retrieving articles from Wikipedia, and that's kind of your like source. I don't know if it's necessarily worth the extra hassle to use RAFT. But let's say you're like a medical company and all of your documents are like diagnoses or like kind of like chart statements for your clients. It makes a lot more sense to use RAFT here just because you really need to be able to identify the right customer. Like if you do like a similarity search for like a customer or like a some specific ID for like equipment and you end up getting 10 different documents on that, it's really important to know which one to use because it could be like life or death in some situations. So just yeah, that's kind of what I took away from this.
Sure. And then, you know, for my takeaways, I think the key thing I got here is RAFT is different than, you know, most fine-tuning techniques in the sense that it's about getting the LLM to use context effectively rather than just making the LLM respond in a specific manner. A lot of times when we're fine-tuning, we're fine-tuning so that the LLM can respond according to the task we're fine-tuning for. This is actually training it to use context, which I think is really important. And this kind of like detailed reasoning that we're incorporating in the training process that is doing this instruction, it just really helps the models make the best of the context. And I think if you have, you know, a use case where you're using RAG and it's not effectively using retrieval you've tried to, change how you're doing retrieval, or you've added more knowledge to your context base, and you still can't get it to respond or attend to the right pieces of context, I think this would be a really good option for you. So it's exciting to see. I think, RAG is still very popular. And I think there is often these issues around it's not using the retrieval context right. And I think RAFT is going to really help you do that. We do have one question in the chat here. I guess we're on our last 5 minutes here. If anyone else has any questions, drop them in the chat or the QA. We're happy to answer them. But Mike C asked, how did you pick the distractors for that training process there?
Yeah, so I guess it really just kind of depends on the data set. So for something like HotpotQA, we kind of filtered through other questions that had like a similar topic and then used context from those questions as distractors, and then some other like we chose some random questions and then used the context for those questions as some of the other distractors. So it's kind of just using the documents for different questions that is not like the question at hand for the data set. But I think that's also like, yeah, I think generally like that's probably the most you can do with like a predefined data set like that, just for kind of getting some results.
Yeah, it sounds like the curation of the data set, there's just going to be some, I think, manual work involved in that. And I think the distractor specifically or something that would be difficult to kind of automate that or leverage, an LLM. You could maybe use an LLM to maybe generate some synthetic kind of context examples. But if you're wanting to use examples from perhaps your actual knowledge base, you're probably just going to have to comb through that data and find the manual and find those pieces of context that make the most sense there.
Yeah, I think, yeah, or like some sort of like randomization, you kind of just choose like random queries and then just provide the context for those in.
Totally.
And
Yeah.
I think that's probably the best way to go about it. That is something that is pretty like intensive to do.
Yeah, for sure. That's a really helpful hint. Any examples of RAFT in production? I don't, this paper's pretty new. You all did this, what, 2-3 months ago?
Yeah,
So yeah, I don't know if you know of any. I think there's a lot of folks who are exploring this right now.
yeah.
Specifically, again, like this is it talks to an issue that a lot of folks have with their RAG system. So I think it's going to gain some traction here. But I'll let you answer too, Sai.
Yeah, I mean, I guess I don't really like necessarily have information about like who's actually using this in production, but I did hear that there are a couple of like medical companies like that are trying to kind of incorporate this. They're in kind of talks with the authors of the paper and seeing if like this is something that's like valuable for them, because their issue traditionally has been that they get a lot of documents, but for them it's really important to kind of identify the best document to use, because let's say like for like kind of like a disease, right? Like there's so much documentation for like different like symptoms, different treatments. So it really makes sense. Like they really need to be able to identify the best document to use in this case. So I did hear that there's some talks with some companies like that about using RAFT, but obviously this is still like a really new paper produced like published like a couple of months ago. So nothing that I know of concretely yet.
Yeah. And just kind of like going beyond just the medical use case, you can imagine that any type of customer facing, system could benefit from this. Anytime you're putting anything in front of a customer or end user, it matters what the LM is outputting as its response. So anytime that is the case and you're struggling to do it with just your out of the box model or your just traditional fine tuning, I think RAFT could really help there. So I do have some confidence that we'll start seeing teams implementing this type of fine tuning for sure. Cool. I guess last call for questions here before we sign off. Going once, twice. All right, everyone. Well, thanks, Sai, so much for walking us through this paper. It's super interesting. I'm excited to see the future research here and what teams do with this. But yeah, thanks everybody for joining. Bye, y'all.